Hello, this lesson is going to be on empirical formulas, and we're going to use percent composition to determine the empirical formula of a compound. Empirical formula is going to give us the lowest whole number ratio of the elements that are present in that compound. So if your empirical formula and molecular formula are the same, which they can be, to get to the molecular formula, it's going to be a simple multiple. If you're trying to go from molecular to empirical formula, you're simply going to reduce the subscripts that are there. So here we have some molecular formulas. We're going to have hydrogen peroxide here at the top. Since the peroxide has 2 hydrogen and 2 oxygen, that is simply going to reduce to HO. Now water, you have 2 and essentially 1 oxygen there. Since those aren't really going to reduce to anything, they're going to remain 2 and 1. Our empirical formula is going to be the same as our molecular formula, H2O. Next we have C3H6. Now are 3 and 6 divisible by the same number? Yes, they can both be divided by 3. That's going to give you 1 carbon and 2 hydrogen. C8H8. Both 8s are divisible by themselves. That's going to give you an empirical formula of CH. C2H2 is also going to give us CH. So sometimes you can have the same empirical formula and get different molecular formulas. Sometimes your molecular and empirical formula are going to be the same. So again, they're simple multiples of each other. So to go from molecular to empirical, you would simply reduce what you have there. Empirical to molecular is what we're getting ready to do. So you're going to start with the percent composition. So this one tells us that we have 50% sulfur and 50% oxygen. Now, 50 and 50 add up to 100%. So if we assume that we have 100 grams of this compound, we can then assume that this means that we have 50 grams of sulfur and 50 grams of oxygen. Okay, so we have our grams. Grams, to do anything else, has to be turned into moles. So we're going to put 1 mole on top. Now the mass of sulfur is 32. So to get rid of that grams unit, we're going to put our 32 grams there on the bottom. When you're doing this step, you're not going to want to round the sig figs here. You're going to want to keep this stretched out so that the next step will get you closer to a whole number. So for this we get 1.5625 mole of sulfur. Oxygen, again, we're going to turn it into a mole. Oxygen weighs 16 grams, so that is going to give us 3.125 moles of oxygen. Okay, we need whole numbers. Neither one of these are whole numbers, so you're going to divide both of these values by the smallest of the 2 in this case. Sometimes you may have 3 that are going to have to be divided out. It just depends on what your compound is. In this case, they're 2. So the smallest number between these 2 values is the 1.5625. So you're going to divide both of them by 1.5625. And that's going to give us obviously 1 for the sulfur, and it's going to give us 2 for the oxygen. So these values are your subscripts. That means that our empirical formula is SO2. We have 1 sulfur, and we're going to have 2 oxygen here. Okay, so the steps for this, you're going to take your grams, you're going to take your percent, make it a gram just by changing the unit. You're then going to convert your grams to moles. Once you have moles, you're going to divide by the smallest number. And then you're going to take that value and that's going to be the number of atoms